what we're getting at is when you're looking for you want to find out what the subnet is and what network it belongs to. Okay, so what subnet group it belongs to. So for this one, we're going to actually do a CIDR 27 because that's going to give us smaller groups and we'll have more networks to work with. So you know that it is a Class C because of 192. All right. You've also verified that it is a Class C because your CIDR is greater than 24. So that means that these three sets of numbers here, you really don't have to touch, okay? You're really only focused on this guy right here, okay? Now, we've got 27. So if we subtract 24 from 27, that leaves 3. We have borrowed 3 bits, all right?
Wait, why 24?
Why 24? Because when you're working with a Class C address, each one of these numbers is represented by 1 bit. Okay? A bit is a 1 or a 0. 8 bits is a byte. Each of these is a byte represented by 8 bits. So if you have borrowed all of these, it is the same as saying that you can just count it out. 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot. So that's 8 and 8, 16. 1, 2, 3, 4, 5, 6, 7, 8. That's 24. Then we're going to 27, 25, 26, 27, then 5 zeros. This is the same as this. Okay? Now, for every one of these that all 8 of them are a 1, that has locked down your address to 255. Which basically means when you give something the subnet mask of 255, it has to match the number given. Because 255 translates to 1 address. Okay? So, anything that does not match 192.168.1, it's not even in the network. So if I asked you, hey, where does 192.168.2.63, where is it at? It's not even in the network. Why? Because I said .2, not .1. Okay? So if it does not match that 1 address, it's not even in the network. So, you go over to the 3rd octet, like I said, we're only really focused on this guy right here with a Class C. So there you see, same thing I did here, saying 24, and I got 3 bits borrowed. If you look at this last bracket, 1, 2, 3. Okay? So now we come over here to what we've been doing, where we got the first value of this one is a 128. Then 64, 32, 16, 8, 4, 2, 1. That is the value of all 8 of these bits. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have borrowed 3 bits. 1, 2, 3. Then the rest are zeros. Okay, now to get what our subnet mask is, you take the values of each of these bits and you add them together. So you say 128 plus 64 equals 192 plus 32 equals 4, that's 224. So now, just based on this, we now know that our subnet is 255, 255, 255, which we got from here. Because remember, we borrowed past 24 bits. Then we go to the added value, 224. That is now the subnet that this resides in. Okay, so now to figure out what group does this one reside in. All right. So remember, we got our set. These are set values. So let's start with 60. That's what we've got. 128 will not go into 60. We're just going to go basic addition, subtraction, math. 128 won't go into 60. 64 will not go into 60. 32 will go into 60. So 32. We subtract that. That comes out to, 28. Okay, 16 will go into 28. That leaves 12. 8 will go into 12, and 4 will go into 12. So 8, that leaves 4, and then 4, that comes out to 0. Which means 2 will not go into 0, and 1 will not go into 0. So now we have the binary value for this guy. So now we use ANDing. Alright, so if I've got 2 zeros, that comes out to a 0. I got 2 zeros, that's a 0. A 0 and a 1 is still 0. So unless it's 1 and 1, it is still 0. Alright, so now we follow this guy up to see what the value is. Now mind you, if there was more than one down here, you would have to do the same thing we did over here. You'd have to add the values together. But because there's only one, then we know it's 32. So the network address that 60 resides in is 192, because it has to match 168.1.32. So now the question is, how would we see this in the brackets we've been doing to begin with? Okay, so let's erase this, get this out of the way so I can draw it on here. So we said to begin with, when you make your little bracket, you've got your network address, your hosts that you can assign, and your broadcast address. Okay? Now, if we know that we have borrowed 3 bits, this tells us that we have 32 total addresses we can use, or total hosts. Okay? So, your first network address is always going to be 0. Your last broadcast address is always going to be 256. Okay? But we know we have 32 total addresses in each subnet. Now, if we've got 32 total addresses in each subnet, remember, 0 is not a null value. It is a number, so it has to count. So if we start with 0, 1, 2, 3, 4, then the 33rd address we know will be 32. This is where I tell you your bracket can be kind of easier. You can count out. Start with 0. 0 is the first value, 2, or 0, 1, 2, 3, and then go all the way till you get to the 32nd number. So the 32nd number is going to be 31. But if you get into this to where you're going through these different numbers, it could be a little bit of a pain to count out 128 numbers. So to me, the easiest way to do it is realize what this number is. This is your total addresses. And know that if you start with 0, then you know your 33rd number is going to be 32. So that's going to start your next bracket. So then if I say, okay, well, if I know that I've got 32 total addresses here and I count 32 itself, then I can add 32 to this number and I get my next subnet. Then I can add 32 to this number, and I get 96. So I could keep going all the way down with however many hosts I've got, and I can get the network, the starting network address for every one of them, until I get down to 250 whatever that ends with 256. But now that I've made this side of the grid, all I got to do is subtract 1 from every number to get the broadcast of the previous one. So if I say, okay, what's the broadcast of this one? 32 subtract 1 is 31. 64 subtract 1 is 63. 96 subtract 1 is 95. So then now I know I can give everything from 1 to 30, everything from 33 to 62, everything from 65 to 94. We don't really have to go much higher because we're just looking for where 60's at. Well, if you're just bare bone looking at it with your own eyes, you notice that 60 is between 33 and 62. So then I know that, oh, my network address is that guy. Guess what? I've already found that. But this is another way to verify it, because if you make this little chart here, then you can just look. So if I use the same information, I said, oh, okay, well, tell me, what bracket does dot 27 reside in? Well, you can look at this chart and say, oh, it resides in zeros. Where does dot 93? Well, dot 93, so it's in 64s. Simple way of verifying. But just with this limited amount of information here, using ANDing, you can figure out the subnet mask, and through the subnet mask and the number that it is, you can determine what network it resides in. So what does that mean? That means that this guy right here can only talk to everything that is given the IP address of dot 33 to dot 62. It cannot talk to anything that is dot 1 through dot 30. It cannot talk to anything that is dot 65 to dot 94. So how do you fix that? You have a router. Now, you use a router to determine how things are translated between. So you come out here and you have your router. So we'll call it router 1. Now, remember, you can only assign stuff that is inside the bracket. So if we say, okay, this group of guys is going to come out and go to port gig 0/0. This group's going to come out and go to gig 0.1. And then this group's going to come out and go to gig 0/2. The address you assign to each of these 3 ports has to reside within that bracket. This then becomes the default gateway for that bracket. Okay? So, if you said everything that's here has a default gateway, we're going to give this port right here dot 1. So we're going to give it the first address from every one of them. Dot 1, this one's going to be dot 33, and then this one's going to be dot 65. Every machine between 2 and 30 now has to have 192.168.1.1 as its default gateway, or it can't talk to anything here, and it can't talk to the internet either. So if this is the internet, it has to know where to go for this guy to translate. So if dot 1 is the default gateway for this bracket, what happens if I give a computer down here the default gateway of dot 1?
It won't be able to communicate.
It won't be able to communicate because it's not physically connected to that port. Remember, the default gateway has to physically go back to a specific port on the router. It doesn't matter if there's 10, 15, 30 switches between here and there, that port is the only port that matters for everything in this group. Okay, so if it's group A and B and C, everything in group A has to be associated to this set of numbers. From the switches all the way to the router. Everything here has to be associated with these numbers. All of it. Anything here has to be associated with these numbers. If it is in group C and it has any number that is less than 65 or greater than 94, it's not going to communicate because it's not going to know where to go. It can't talk to anything that is not in that bracket. This is why when you're dividing up subnets for locations, make sure you leave enough room for growth. Because if you don't, you run out of addresses, you're either going to have to create a whole nother subnet, or you're going to have to go back and reroute or rewrite every one of your subnets. Okay? Now, when it comes to borrowing bits, if you think of your network as a sheet of paper, every bit that you borrow divides it in half. So if you always start with 0 and end with 256, if you borrow one bit, you divided it in half. Now remember I said, if I divide it in half, I've got 128 usable addresses. So that means my 129th address is 128, 127. I know it's 5, let's be silly. So now everything from 1 to 126 can talk. Everything from 129 to 255 can talk. I borrow another bit. I've now divided it in half. That's 64 addresses. So 128 plus 64. That's 192. So then 191. See how it keeps adding on, but it's simple if you think about it. If you take the time to just look at the numbers, none of these are going to change. So every time that I divide it by getting another bit, certain numbers in the bracket are not going to change. So if I divided it again and that gives me 32 addresses, so then I have 0 to 31, 32 to 63, 64 to 96, 95, 96 to 127, 128 to add 32, so 0, carry the 1, 60, then I got 160 will be here, that'll be 159, and que sera, sera. Every time you borrow a bit, you have to divide your network again. So if you keep going, you notice that it gets smaller and smaller and smaller and smaller. Then you divide it again by borrowing another set of bits. But if you'll notice, once you make this little grid, that certain numbers never change. So if I divide it again to 16, it keeps going on and on and on. Well, actually to 8, now I've divided it to 8, that's 7, and then 8, and it keeps going on and on and on. Now, is this making sense, or am I losing y'all?
That makes sense.
Yeah, this makes sense.
That makes sense, yeah.
Yeah. You getting it now?
Yeah.
I was trying to think of what else I was wanting to get to. So you keep dividing it down, so it keeps getting exponentially smaller.
Wait, would the CIDR change if, say, you put it as 61 or you change that to like 30? The CIDR, the last digit, the 60?
This 60?
Yeah, if it changed to like 30 with the CIDR, or like 120 something, would the CIDR change?
No.
Okay.
The CIDR is completely independent of this number. This number, you could say, where does 160 with a CIDR 27. This part would not change. You still borrow the 3 bits, but now you've got 160, so it would change up our math. So instead of, you know, being 60 and saying, hey, will 128 go into it? No. Now it's 160, so 128 go into it? Yes. So then that's 2, that's 3, so 32. So now the numbers change up, and the binary address for 160 looks like this. So now this changes to here. So now we've got 32 plus 128. So if we say 128 plus 32, then that's going to be 0 carry 1. That's 160. So then that means 160 is actually the network address of the network it resides in. So I can't even assign that to an item, because now that I did my ANDing, I realized that 160 is the network address itself. But now what happens if I said, okay, well, we know what the network address is, I can't assign it, so what if I said I'm looking for 162? So then I come over here, I change that up, so now my binary looks like that, but hey, guess what? My ANDing still stays the same, so it still gives me 160, so I know I'm still in that network.
Okay.
Yeah. So let's say I changed it up and said 192. All right, that changes up my math again. So I got 192. Now the 128 will go into 192. So that'll be 12. So that's 4. That'll be 8. That's 6. 64. So now it looks like this. It looks like that. So now I say, what is 128 plus 64 is 192. So now I know that, guess what? That's the network address for my network, because 192 comes out with the ANDing equals 192. So now I know that's my network address. So now I change this up and say 200. All right, where's 200 at? So I say 200, and I say 128 minus 200, that's going to be 2, that's going to be 7, so 72, so 64 from 72, that's going to be 8. All right, so then now I know that this address changes to, so I did 128, yes, 64 is yes, 32, no, 16, no, 8, no, no, no. I do my ANDing, guess what? Still stays exactly the same, so I know that 200, that the network address for the 200 bracket is 192.168.1.192. This never changes. So once you've got this top part, I could change this number all day long. And all I'm going to be doing is changing this, which is going to change my ANDing, which is going to give me a different network address, which is going to tell me the group of computers that that number can talk to. So I know it can talk to 192. So if I say 192 plus 32, then that means my next network is 4, so carry the 3, that's 32, so that's going to be 9, 10, 12, 224, so 223, so 193 through 122. Those are the groups of computers that this guy can talk to. And I was telling other folks, one way you can always check your little bracketing thing, this is set in stone. Notice how there's 4 numbers here? Even, odd, even, odd. It will always be even, odd, even, odd. Your network address will always be an even number. Your broadcast address will always be an odd number. So just remember that when you're writing down all 4 addresses in your little network, hosts, and then broadcast grid. This is going to be even. This is going to be odd. This is going to be even. This is going to be odd. Every time. Every time. Cool?
Okay.
That's it. That's